I want to do a quick demonstration of a phased array inspection of a weld. And I'm going to use my Olympus OmniScan SX machine to perform this test. I have a 32 element phase array transducer attached, and the wedge. This is a 5L32-A11 transducer, and the SA11N55S wedge. And what I did was I positioned my transducer, the front of the wedge, 1 inch from the center line of my weld. And the reason I did that is because I want the first leg of my 70 degree to capture the root of the weld. And I'll show you that in a minute. But instead of doing a raster scan, we're just going to scan across this weld. I have this magnet here to maintain my 1 inch distance from the center line to the front of the wedge. And let me zoom in, and I apologize, the screen is kind of hard to see, so let me zoom in. Okay, the first thing we want to do is set up this test, and right here hit the full the menu screen and press this button. There's a setup wizard that makes it very simple to set up this test. The wizard, the first thing it comes to is to set up your part in your weld. So hit start, and my weld, this plate, is 600 thousandths thick. It's mild steel. It's plate, and it's an offset weld. You have several different options. This is an offset weld, meaning that at the root there's a gap there. It's offset. Hit the next button, and it wants to know that it's a symmetrical weld. There's different options, but this is symmetrical. Next. It wants to know the height, and up here you can see there's some help. The height is the height of our land. It's 80 thousandths, and then the offset is from the center line to your land 50 thousandths, for a total of 100 thousandths gap. Next, the height. This is 600 thousandths or 0.6 inches. 80 thousandths land, 520 thousandths is the rest of the height, total of 600 thousandths of an inch or 0.6 inches. And the bevel is 30 degree. Next, this is the weld fill sizing. I'm not going to do anything with that, just next. And it wants to finish, but I've already entered this information, so let me back out. And we'll go to the next step, which is the setup for your scan. Hit start. I want to set it up as a phase array group. My application is a weld. Next. This is a smart probe. When you plug into the system, it will recognize it, and it sees that it's a 5 megahertz 32 element phase array probe. As far as the wedge goes, you have to enter that information manually from the tables that are provided. Next. It's a sectorial scan. Shows the different scans you can do. I chose a sectorial scan, and it's a 16 element of the 32 are used. I'm using 16 of the 32 elements in this transducer. Next, I'm starting with the first element. In the back is the first element all the way up to 32. I'm using the first 16. Minimum angle is 40 degrees. That's represented right here. That's 40 degrees. And then my maximum angle is 70 degrees. So I have a total of 40 to 70 degrees incremented in one degree angle increment. So 40 degrees, 70 degrees, And I'll show you in a minute why I moved 1 inch back from the center line. Hit the next. Right here, I'm using unfocused, but my index offset is -1 inch, meaning from the center line to the front of my wedge is -1 inch. Since I'm on the left side of the weld, it's negative, this side positive. The reason I moved back 1 inch from the front to the center line is because I want my 70 degree to come down and capture the root of my weld. And you can see these other angles, they come up in the second leg. So I have good coverage on that weld. Next thing you would do is generate, but I've already generated, so let me back out of this thing. And let me go to full screen. Well, first let me show you. This is the A scan right here. This is the gate. On the sectorial scan, you see my weld overlay. Top of the weld, root. Top or toe of the weld, root for different legs. This is right here is our gate. It corresponds with the A scan gate. And then this line here is our angle. If I press the angle, I can rotate it all the way out to 70 degrees. See how that sweeps? 1 degree at a time I've set up down to 40. So for simplicity's sake, let me go full screen on this thing. And I'm going to look at this weld. I'm going to go across. So let's look at the sectorial scan for a minute. We can see that is the far side toe of the weld, a normal geometric reflection. And that is the far side of the root, which also gives us a geometric feedback. This is normal. So let's watch for changes in this signal. Coming across, right there, you see that? Right there, some good energy coming back right on the side wall. See that right on the side wall? Now, my angle is at 70 degrees or 40 degrees. Let me change that angle. Let me bring that angle up and hit right in the middle of that red spot. That's a lot of energy coming back. And you can see my A scan, now I have 56 degrees. My A scan is giving me good amplitude, and that's 56 degrees right there. So right there, I'm hitting a big reflector right on the sidewall of this weld, and it pretty much looks like it is lack of sidewall fusion. Another thing I can do, I can kind of rotate or rock my probe, and you see how I just barely move it, and that signal drops off, indicating I'm hitting a machine surface that isn't fused with the weld process. And another thing, 56 degrees, this weld prep is at 30 degrees. I am catching on my second leg with 56 degrees, I'm catching that big reflector, meaning basically 50 degrees, 56, 60 degrees, striking that 30 degree bevel is giving me good reflection coming back. And we can also change from sectorial scan. I can change to just the A scan or the sectorial scan. Let's just look at the sectorial scan. That's kind of a good view of, you see that indication right there. Goes away, come over, comes in. And I can increase that. I can kind of zoom in on it. Let's do that. Like this. There. Really did a good job zooming in. And now we can kind of get our through wall on that. Let me hit this angle and rotate it down here. And right about in that orange, right in that area, it's probably around a 6 dB type of drop. You can see the bright red, then the color palette, it kind of fades down. So right there, if I look, this shows my signal, the depth of this thing right here. Sorry. is just about 0.9 inches. The sound path is about almost 1.89 inches, and then the PA, which is the from the front of the wedge to the indication, is 0.67 inches. What puts us on the left side of our weld because it is a sidewall. So the depth is just about 0.9 inches. Let me move that angle up, and looks like the top of that indication is about 2.4. So minus 0.9 is about 1.5 inch through wall. From here to here, that's the through wall. And here I have the key, and this is indeed lack of sidewall fusion on this thing. The key says that it's the through wall is 150 thousandths. That's kind of what we came up with. But that 56 degree is coming up, striking this, and give us a good reflector back. Another thing I'm going to show you in another video, I want to show you how to calibrate, because in that setup wizard, the last thing is calibration. I'll show that to you.